In the last video, we discussed how we can take a number of moles of one thing, one reactant or even product, in a chemical reaction, and using the balanced chemical equation, we can work out how many moles of something else in the chemical reaction we would need to either react with it, or we would need or could be produced from that amount of molecule reacting. In this video, we're going to take that one step further, and we are going to look at if we know the mass of something that is reacting, what mass of something else would either be needed to react or would be produced if we're looking at a product, just depending on what we are comparing it to. So, we have this multimole ratio that we looked at in the last video. If we know the balanced chemical equation, we know how many moles of one thing, let me rephrase that. We know from the balanced chemical equation what the ratio is between the moles of one thing and the moles of something else. This is what we looked at back here. So, like the ratio here was a 3 to 2 ratio between these things. So as long as we have that balanced chemical equation, we can work out how many moles of one thing would be consumed or produced by a certain number of moles of something else in the chemical reaction. To take that to the mass of something that is consumed or produced, it's really not anything new. This is something that we've done before in a previous chapter. We're just going to tack on to the beginning and the end of the process a mass to mole or moles to mass conversion. So if, for example, we know the mass of something that is reacting, and we want to know the mass of the product that is produced when this stuff reacts, what we're going to do is we're going to convert the mass of the reactant into moles of reactant. Now, this is done exactly the same as we've done in previous chapters. You're just going to look up the molar mass for that molecule or atom using the periodic table and use the molar mass to convert to moles. Once we know how many moles of that thing we have, we can use the balanced chemical equation to work out, given this number of moles here, how many moles of the second thing is going to be produced or consumed. And then to work out the mass of that second thing, it's once again just a molar mass conversion. So you would look up the molar mass of that second thing on the periodic table and convert it into mass, convert the number of moles into mass. So these, anytime we're going from the mass of one thing to the mass of something else in the same chemical reaction, the process is always going to be a mass to moles of something else to mass process. It's always that three-step process, going from mass to moles to moles to mass. It's always a three-step process with 2 molar mass conversions and 1 conversion using the ratio from the balanced chemical equation. So let's look at a few examples of this. First one here asks us how many grams of CO2 are produced from the combustion of 500 grams of pure octane. So, we have, let's see here, 2 moles of octane reacting with 25 moles of oxygen to produce 16 moles of CO2 and 18 moles of water. So we want to know how many grams of this are produced from 500 grams of this. So we're going from here to here. Given this mass, how much of this is produced? So once again, it's going to be a mass to moles to moles to mass conversion, where we switch the thing that we're looking at halfway through from one molecule to another. So the first thing we're going to do is we're going to convert our 500 grams of octane into a number of moles of octane. So we have 500 grams, and I'm just writing out 500 instead of 5.0 times 10 to the 2, just because it's smaller. Save myself some room. And this is octane. The molar mass of octane, I don't know off the top of my head. Let's see. So we have 8 carbons, which are 12.01 each, plus 18 hydrogens that are 1.01 each. And that gives me 115.09. Okay. Grams of octane for every 1 mole of octane. So that is this. It's just the molar mass of octane. I just went to the periodic table, found carbon, multiplied it by 8, found hydrogen, multiplied it by 18, and added those two together to get octane. And remember, we ignore the coefficients when we're just doing moles to mass conversion. We are not going to ignore the coefficients for this next step, though. So the next step here is the mole to mole conversion. So we're going from moles of octane into moles of CO2. And this ratio is coming straight from those coefficients. So this balanced chemical equation tells me that for every 2 octanes, I'm going to produce 16 carbon dioxides. So I'm going to put the 2 moles of octane on the bottom, because I want it to cancel out with the moles of octane up here. And I'm going to put 16 moles of CO2 on the top. And so then the last conversion, so now we've done this one, the last conversion is going to be from moles of CO2 into grams of CO2. And CO2, I think, is 44, but I'm going to double check real quick. So we have 12.01 plus 2 times 16. Yeah, 44.01. So for every 1 mole of CO2, we have 44.01 grams of CO2. All right. So notice there, we have 3 conversion factors. Each of them corresponds with one of these. Conversion from mass to moles, that's our first conversion factor. Conversion from moles of one thing to moles of something else, that's our second conversion factor. And then converting from moles of that second thing into mass of the second thing, that is our third conversion factor. 1, 2, 3. Like I said, it will always be this way if you're going from the mass of something to mass of something else. Now sometimes it'll be a little bit different, and maybe the question won't ask for you to find the mass, it will only ask you to find the number of moles, in which case you would just leave off the last conversion factor. You just wouldn't do that one. So, if I check my units here, grams of octane cancel, moles of octane cancel, moles of CO2 cancel, leaving me with grams of CO2. So I have 500 divided by 115.09 divided by 2 times 44.01. And that gives me 95.6. We'll say I'll cut it off there. Grams of CO2. That is how much carbon dioxide is produced when 500 grams of octane is burnt up. I think I'm actually going to call it there for this video. We'll leave it there. In the next video, we will do examples 8.2 and 8.3, and so the whole video will just be those two examples. So I will see you all in that next video.